So I've been getting a lot of questions about the Sapling assignment number 1 and specifically question 8. So question 8 is a little bit tricky. We're talking about a specific isotope, and we've got a sample of a naturally occurring sample of that element, and we're asked questions about a specific isotope within that naturally occurring sample. So the question comes in two parts. And I've just copied a little bit out of the version that I see when I go to Sapling. You might have a different isotope or a different element altogether. But I thought I'd just take a few minutes and just go through the basics of this question so that it makes a little bit more sense to everyone. Basically, we're told a couple of things. We're told that a given isotope has a certain percent abundance. So I'm told that tin-124, that isotope is about 5.8% abundant. So that means any naturally occurring sample of tin is only 5.8% tin-124, and it's mostly other isotopes of tin. And the question that I'm asked is if I have a 20-gram sample of specifically naturally occurring tin, so if I've got 20-gram sample of naturally occurring tin, how many atoms of those are tin-124 specifically? So it's a bit tricky because your natural inclination is just to say, well, 5.8% of the 20 grams is the tin-124, but you'd be making a pretty big mistake there because you'd be assuming that all of the tin weighed the same, so 5.8% of it would be 5.8% of the mass. But the problem is that every isotope of tin weighs something different, so when you add up its mass, the percentages are not the same as the percentage in terms of just the number of atoms in general. And we only know that according to the number of atoms, only 5.8% of those are tin-124. So the first thing we've got to do is we have to realize that this is naturally occurring tin, and so we want to take a look at the periodic table. So if we take a look at the periodic table, the entry for tin has 118.71 as the recorded atomic mass of tin. So that means that an average naturally occurring sample of tin, the average atomic mass is 118.71. Now, 118.71, that is a number in the atomic mass units. So that's on the periodic table, it's written in atomic mass units, but that is exactly equivalent to 118.71 grams per mole. So atomic mass units and grams per mole, completely interchangeable. That's on purpose. And so for my case, I know that for a given number of grams that I've got, I can figure out how many moles I've got. And moles is another word. It's like we call it a chemist's dozen. So when I use the word dozen, I think everybody knows that I mean 12. When I use the word mole, what I mean is not 12, but 6.022 times 10 to the 23 things per mole. So a mole means this really, really, really large number. So the concept of a mole was developed to help us talk about chemical things, these tiny little atoms, in numbers that made sense to us. So for example, 118 grams. So if I have 118 grams, that's something I can conceptualize. But 118 grams of tin actually corresponds to this number of atoms of tin. So that's a very, very large number, hard to conceptualize, but we can use it. So in this particular case, I don't have 118 grams. I've only got 20 grams. So what I want to do is I want to convert that 20 grams. So I know I've got 20 grams of tin, and what I'd like to know is how many atoms of tin do I have? And I can use this relationship, this atomic mass here, to convert between grams and moles. And that's very commonly done. So I've got grams. I'd like to know how many moles I've got. And so I can take whatever number I've got from the periodic table, and over here I notice that it's grams. 118 grams is the same as 1 mole. So I just write that same number over here. This is exactly the same. I haven't done any tricks here. So I know that 118.71 grams is 1 mole, and I can do the math here. Grams will cancel with grams. And this number works out to be something like 0.1684. I'm going to want to keep a whole bunch of decimal places here, and I'll truncate it at the end. So right now I know that I've got about 16% of a mole. So I don't actually have this number of tin atoms. I've got 16% of that number of tin atoms. So let's figure out what that actually is. So I know that a mole is 6.02 times 10 to the 23 things in every mole. And in this particular case, I know that I've got 16% of a mole. So it's exactly like saying if I had, 16% of a dozen, how's that? So you would think about 16% of 12, and what's that? So right now I want 16% of this very large number. So 16% of that number works out to be something like 1.01457 times 10 to the 23 atoms. So I haven't written the word atoms there very clearly, but you get the point. So I can fill in atoms over here. If you want to keep track of units, the moles will go away. So I've figured out that in this sample, in the 20 grams that I know I've got that many atoms. But those atoms, remember, this is a naturally occurring sample of tin. So there's going to be certainly some tin 124 in there, but there's going to be other flavors of tin as well, other isotopes. And the question is only asking me about the tin 124. But now I can finally use that number that the question gave me. The question told me that I had 5.8%, so a naturally occurring sample of tin is 5.8% tin 124. So if I've got this number of atoms of tin, and it's a naturally occurring sample, I know that 5.8% of this number is how many tin 124 atoms I have specifically. So if I carry that number down, 1.01457 times 10 to the 23, huge number of atoms. I know that 5.8% of them, so multiply by 0.058, 5.8% of them are specifically tin 124, and so what I work that out to be is something like 5.88 times 10 to the 21 atoms. And specifically, I guess I want to be specific here, this is specifically atoms of tin 124. So that's how you get at that first question we had here. So how do I get at, how many specific atoms of that specific isotope there is? So basically 3 steps here. The second part of the question, once you've done the first part, is actually a little bit simpler, and it says, now what we want to do is we want to talk about just these atoms. So you've worked out how many tin 124 atoms you've got. Now the question says, what is the total mass of that set of atoms? So once we know this set of atoms, what does this set of atoms weigh? So in order to do that, we want to think about moles again. Generally, we're always interconverting back between moles and grams. But the thing we know about tin 124, although it's not written down explicitly for us, we can assume that the mass of tin 124 is approximately 124. Now we know from our lectures in class that that's not going to be exactly true. The mass number does not equal the atomic mass of a particular isotope, but it's pretty close. It turns out that it's a reasonable approximation, and Sapling likes to use that approximation. So let's assume that tin 124 weighs approximately 124 atomic mass units, which we've just learned is also exactly equal to 124 grams per mole. So we know how to figure out how many grams as long as we know how many moles of tin 124 we've got. And we don't. We know how many atoms. So let's convert that. So what we'll do is we'll say that 5.88 times 10 to the 21 atoms of tin 124 is the same as, so I want to know how many moles is that. Well, I know that 1 mole is 6.022 times 10 to the 23 atoms. So now my atoms will cancel here in this conversion. And so that's going to give me how many moles of tin I've got. But I can keep going here and kind of cut through a step and say that I know that it will be 124 grams for every one of those moles that I have. And so I can do this full conversion all at once. And so I can take my 5.88 times 10 to the 21, multiply it by 124, divide it by 6.02 times 10 to the 23. I can do that in any order I like. And if I work it out, I will discover that that works out to 1.21 grams. So basically, that's really the whole question. 1.21 grams is how much specifically that tin 124 would weigh in this sample. And there would be specifically 5.88 times 10 to the 21 atoms of that particular isotope in this sample. So definitely a little bit tricky, lots to think about there. Hopefully that makes it make a little bit more sense for you in your specific case. You might not have tin, but that's how it works. So thanks for the questions, and keep them coming.